We're going to look at our third way of solving quadratics, and this is using the quadratic formula. Our a value is in front of the x squared, our b value is in front of the x, and our c value is the number by itself. This only happens when it's set equal to 0. And so the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So for our first one, our a value is 1, b value is negative 2, and c value is 8. So when I plug it in, I have a negative and a negative, which would be a positive. So that's why it's positive 2, plus or minus the square root. Then I have b squared, so negative 2 squared, minus 4 times 1 times 8, all over 2 times 1. So that becomes 2 plus or minus the square root. Negative 2 squared is 4, minus 4 times 1 times 8 is 32, all over 2. 4 minus 32 would give us negative 28. So we have 2 plus or minus the square root of negative 28 over 2. And we know that negative 28 is negative 1, 4, and 7. So x equals 2 plus or minus. The square root of 4 is 2. The square root of negative 1 is I, so that would be 2i square root of 7, all over 2. Now, if we divide all of the terms by 2, that gives us 1 plus or minus I square root of 7. Now, looking at letter B, we're going to set it equal to 0. So I have 3x squared minus x minus 7 equals 0. My a value is 3, b value is negative 1, and c value is negative 7. So I have x equals, once again, this is a negative and a negative, which is a positive. So 1 plus or minus the square root. I have negative 1 squared minus 4 times 3 times negative 7, all over 2 times 3. X is equal to 1 plus or minus the square root. Negative 1 squared is 1. Negative negative is a positive, so that would be a plus. 12 times 7 is 84, all over 6. 1 plus 84 is 85, and that does not simplify, so we have 1 plus or minus the square root of 85, all over 6. Now for letter C, our last one, we have our a value being 5, our b value being 2, and our c value being 4. So we have x equals negative 2 plus or minus the square root. We have 2 squared minus 4 times 5 times 4, all over 2 times 5. So x equals negative 2 plus or minus the square root. We have 4 minus 4 times 5 is 20, times 4 is 80. We know that 4 minus 80 is 76, so x equals negative 2 plus or minus the square root of negative 76, all over 10. Now, negative 76 would be negative 1, negative 4, and 19. Square root of negative 1 is I, square root of 4 is 2. So we have negative 2 plus or minus 2i square root of 19 all over 10. And we can see that they're all divisible by 2. So if we divide them all by 2, that gives us negative 1 plus or minus I square root of 19 all over 5. Now we're going to look at the discriminant. The discriminant is the term inside the quadratic formula. So if we look at our quadratic formula, what we see is b squared minus 4ac, and that right there is the discriminant. Because there's a plus or minus in front of it, what we notice is that if it's less than 0, that's two imaginary solutions. That's where we're getting the I, like the one right above. If it's equal to 0, it's one real solution, because if we have a square root of 0, whether we add 0 or subtract 0, it only gives us one answer. And if it's a positive, we get two real solutions, like letter B. So we're going to just find how many solutions there are. We're not solving it. So our A value is going to be 1, B value is -6, C value is 9. We have -6 squared minus 4 times 1 times 9. That's 36 minus 36, which is 0. So that means that there is one real solution. Now, if we're looking at the next one, our A value is 4, our B value is 8, our C value is 1. So we have 8 squared minus 4 times 1 times 1. That would be 64. 4 times 1. That would be 64 minus 16, which would give us 48. That would be two real solutions. And for our last one, I'm going to move the 4 over. So that gives me 7x squared minus x plus 4 equals 0. So A is 7, B is -1, and C is 4. That would be -1 squared minus 4 times 7 times 4. That would be 1 minus 112, which is -111. And that would be two imaginary solutions.